So how is the value of p of a related to the remainder of p of x divided by x minus a? So p of a is like, all right, you've got a function and you evaluate the function for a. Dividing it is what we just did, right? So let's say a was 3. So p of 3 would be evaluating a function, substituting 3 in for every x value in the function. Dividing it by x minus 3 would be dividing it by x minus 3, but notice how that a is the same, right? So the example we're going to look at here, you have p of x is equal to that function. We're going to use synthetic division to divide it by x plus 5. To identify the value of a, write the divisor x plus 5 in the form x minus a. So a is negative 5. So remember we were talking about essentially in synthetic division, whatever is happening to the number in that expression, you do the opposite. The divisor is the opposite, so it's going to be negative 5. So again, you got negative 5 in the box. You drop 1, multiply. That's actually a mistake right there. That should be negative 5 right here. But when they add it down, they are treating it like a negative. So it would be 5 there. Negative 5 times 5 is negative 25. You add down, you get 4. Negative 5 times 4 is negative 20. You add down, and you get 4. So the remainder is 4. So the question was, what would happen if you evaluated the function for that negative 5? You evaluate, substitute negative 5 in for every x in the function. And what you end up with is positive 4. Notice how it's the same as the remainder. So p of negative 5 is the remainder 4 of p of x divided by x minus negative 5. So you get the same thing when you evaluate the function as the remainder when you divided it by that. So then here's the general rule. Looking at it generally, basically this is a proof, but it's just proving that, right, that the remainder is the same as just evaluating the function to begin with. Let's take a look at another example. So it says use synthetic division to show that the remainder of that function divided by x plus 2 is equal to f of negative 2. So work it out both ways and show that it's the same answer. All right, so pause it, give that a try, and then come back and we can look at our answers together. All right, so I did synthetic division, dividing by x plus 2, which means negative 2 is the number. I went through the whole process that we've gone over a couple times, ended up with 5 as my remainder. When I evaluate it for f of negative 2, meaning I substitute negative 2 in for x, simplified, I got the same 5. All right, that's what's called the remainder theorem, is that when the remainder you get when you do long division, polynomial division, is equivalent to when you evaluate for that number of the divisor. So there you go. Well, let me know if you have questions on that. Let's take a look at example 4.